Imagine you are staring at a pot of water on your kitchen stove. Your stomach is growling. But for some reason, that water just will not boil. We have all heard the old saying that a watched pot never boils. But in the world of classical physics, that is just a trick of the mind. Time passes, heat transfers, and eventually, the bubbles appear. But if we shrink down to the scale of atoms and particles, that old wives' tale actually becomes a fundamental law of reality. In the world of quantum mechanics, if you keep looking at something, you can literally freeze it in time. This is the Quantum Zeno Effect, and it is easily one of the most bizarre things humans have ever discovered about the universe. It suggests that by the mere act of observing a system, we can stop it from ever changing. To understand why this happens, we have to talk about how quantum things exist before we look at them. Imagine a radioactive atom that is eventually going to decay. In the quantum world, it does not just sit there waiting. It exists in a weird blur of being both decayed and not decayed at the same time. This is called superposition. As soon as we measure it, the universe is forced to pick a side. It snaps out of that blur and becomes one or the other. This is where the magic happens. Every time we check on the atom, we reset its clock. Think of it like a game of red light, green light. Every time you turn around to look at the players, they have to stop exactly where they are. In the quantum realm, if you look fast enough and often enough, the player never gets a chance to even take a single step. Let's look at a concrete example from a famous lab experiment. Scientists took a group of supercooled ions and used lasers to transition them between two energy states. Under normal conditions, these ions would flip back and forth like a pendulum. But when the researchers bombarded the ions with ultra-fast pulses of light to check their status, the flipping stopped entirely. The ions were essentially paralyzed by the observation. They were stuck in their initial state simply because they were being watched thousands of times per second. This is not just a laboratory curiosity either. It tells us something deep about the nature of information. It means that the way we extract data from the universe is not a passive act. We are not just quiet observers watching a movie. We are active participants who change the plot just by showing up. It is like trying to photograph a spinning fan. If you take a high-speed photo with a flash, the blades look perfectly still. In quantum physics, if you take enough photos in a row, the fan literally cannot spin. This effect could eventually lead to breakthroughs in quantum computing, helping us keep fragile data from disappearing. It turns out that the secret to stopping time is not a sci-fi machine, but just a really fast camera and a lot of patience. If you found this dive into the weird side of physics fascinating, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. What other quantum phenomena blow your mind? Let me know in the comments below, and let's get a conversation started about the weird reality we live in.